There's this insatiable demand right now for AI to process just massive amounts of information. We're not talking about just an article. We're talking about an entire library of books, or an entire company's worth of code. This is what we call long context, and it's a huge deal. But there's this invisible wall that AIs keep slamming into. So let's dive in and see how some researchers at Xiaomi might have just found a sledgehammer to break right through it.
All right, so the first chapter in this story really starts with this fundamental barrier, a core problem in the AI models that power pretty much everything you've heard of, like ChatGPT. It's called the long context problem.
So why is this so hard? I mean, it seems simple enough, right? Just feed it more text. But the way these models are built, well, it creates this absolutely staggering computational headache that doesn't just grow, it grows exponentially.
And this visualizes the problem perfectly. As the text you're feeding the AI gets longer, that's the document on the left, the computational cost on the right doesn't just go up a little bit. No, it skyrockets. The AI isn't just working harder, it's working exponentially harder, and it hits a wall where things just become totally impractical.
Okay, so this is the villain of our story. It's called quadratic scaling. Think about it like this. Imagine a researcher trying to understand a library. To understand a new book, they don't just read that one book. No, they have to reread every single book they've already read and compare it to the new one. So book 1, no problem. Book 2, you compare it to book 1. Book 3, you compare it to books 1 and 2. You can see where this is going. By the time you get to book 1,000, it's a completely impossible task. And that's exactly what the AI's attention mechanism does. It's a huge, huge bottleneck.
So naturally, very smart people came up with what seemed like a clever workaround. It was a really intuitive first try at solving this scaling nightmare. Let's take a look at how that went.
The idea was called sparse attention, and the concept is super simple. Instead of looking at absolutely everything, just have the AI focus on the most important bits of information. It's like our researcher deciding, hey, to save time, I'm only going to read the books with the flashiest, most interesting-looking covers. Seems logical, right?
Well, turns out this approach had two really big problems. First, how does the AI even know what's important before reading it? It has to guess. It uses these unreliable shortcuts, or proxies. It's basically judging a book by its cover, and it often gets it wrong. But second, and this is the real deal breaker, while it did cut down on some of the work, it didn't solve the memory problem. The AI's short-term memory, what's technically called the KV cache, still had to be absolutely massive. Think of it as a giant notepad that has to hold every single detail just in case. So it was a partial fix that left the biggest bottleneck completely untouched.
And that brings us to the breakthrough. Researchers at Xiaomi's LLM core team came up with a new architecture designed to tackle both of those problems at the exact same time.
And the core idea, right out of the paper's abstract, is brilliantly simple. Don't choose between the slow but thorough full attention and the fast but flawed sparse attention. Instead, you combine them. You interleave them in this really smart hybrid structure.
Let's go back to our library analogy. What HySparse does is basically create a research team. You have one senior, absolutely brilliant researcher who quickly but comprehensively scans everything. This is your full attention layer. Then, instead of doing all the deep reading themselves, they create a perfect, precise reading list and hand it out to a whole team of junior researchers. These are the sparse attention layers. And the key is, they don't have to guess what's important anymore. They've been told exactly where to look.
Okay, so how does this tag team approach actually work under the hood? Let's get into the two key innovations that make this whole thing possible. Now, this diagram might look a little complex at first, but it shows that tag team in action. If you follow the flow from the bottom up, that orange box at the bottom, that's our senior researcher, the full attention layer. It looks at everything. But then, look what it does. It passes critical information, those block indices, upwards to that whole stack of red, sparse attention layers. It's one smart layer guiding a whole team of fast, efficient specialists. It's a cascade of intelligence.
Let's just break it down step by step. First, that one full attention layer acts like a supervisor, analyzing the whole text to figure out what really matters. Second, it creates that perfect oracle list of key pieces, and this is the really clever part. It shares its short-term memory, the KV cache. Finally, that team of sparse attention layers takes the list, takes the shared memory, and gets to work, focusing only on what matters with zero guesswork.
So this first innovation is called Oracle Token Selection. And honestly, the name is perfect. That full attention layer literally becomes an oracle for the sparse layers. This completely eliminates that first huge problem of guessing. The model isn't judging books by their covers anymore. It has a perfect guide telling it exactly what to read.
And the second big innovation is KV cache sharing. This one directly attacks that second huge problem we talked about, the memory bottleneck. The sparse layers don't need their own gigantic short-term memory banks. They just reuse or recycle the memory that was already created by the smart full attention layer. No redundant memory usage, no more bottleneck. It is just an incredibly efficient design.
So, the theory is really elegant. It's a beautiful solution on paper. But, the real question is always, does it actually hold up in the real world? Let's look at the numbers.
Let's just start with a hero number, 10x. For a massive 80 billion parameter model, HySparse reduced the required memory, that KV cache storage we keep talking about, by nearly 10 times. That is an absolutely staggering leap in efficiency.
But here's the real kicker. It's not just more efficient, it's actually better. I mean, just look at this table. On these standard industry tests for general knowledge, for math, and even for coding, the far more efficient HySparse model actually scored higher than the brute force, super expensive full attention model. This is the ultimate dream in engineering, right? Doing more with less.
And this quote from the researchers themselves just sums it up perfectly. They proved that you can dramatically cut down on the most expensive parts of the model without hurting its performance at all. In fact, you might even improve it. For their 80 billion parameter model, get this, only 5 out of 49 layers were the expensive full attention type. Just 5.
So let's just zoom out for a second. Why does one clever architecture matter so much? Because this is about way more than just a single research paper.
Look, HySparse is way more than just some small improvement. It feels like a fundamental shift. It solves the two biggest flaws of the old approaches by getting rid of the guesswork and fixing the memory problem. It gives us that rare, beautiful win-win of being both more efficient and more effective. And that really represents a new design philosophy, a new path toward building AI that is not only more powerful, but also more accessible and sustainable for everyone to use. And that kind of leaves us with one final thought. For years, the story of AI has just been go bigger. Bigger models, more data, more computing power. But innovations like HySparse are showing us that smarter can be way better than just bigger. So now that we have a clear path to make AI both incredibly powerful and radically efficient, what new frontiers does that open up? What problems can we finally start to solve that were simply out of our reach before?
So what if I told you that the standard way we've been teaching our most powerful AIs, the exact method used for years by all the biggest labs in the world, has a fundamental flaw? Well, today we're diving into a breakthrough that's shaking up the very foundations of AI training, all by fixing a huge problem that was hiding in plain sight. This is the question, right? It's the tightrope every AI developer has to walk. You've got this brilliant model, but every single time you try to make it better, more helpful, more honest, you run this massive risk of completely breaking the thing that made it so great in the first place. It's a super high-stakes balancing act between making progress and, well, total catastrophe. So how do you walk that tightrope? Well, for the most part, it's through a process called reinforcement learning. The easiest way to think about it is like training a very, very smart dog. The AI gives you an answer. If it's a good one, it gets a reward, like a little digital treat. If it's wrong, it gets a penalty. Now, just imagine doing that millions and millions of times. Eventually, the AI starts to learn exactly how you want it to behave. Now, for years, the undisputed king of this whole training game has been an algorithm called proximal policy optimization, or PPO. The real genius of PPO is its built-in safety net. It basically forces the AI to only make small, safe changes, so it doesn't suddenly go off the rails during training. It's the reason our most advanced AIs stay on a pretty tight leash. And make no mistake, PPO is the bedrock of modern AI. It's reliable, it's trusted, it's the engine behind so many of the AIs we use every single day. But here's the thing. It turns out that even the strongest bedrock can have a tiny crack. And in the world of AI, a tiny crack can lead to a spectacular failure. So where does this super trusted method go wrong? Well, it all comes down to a really simple but absolutely critical mistake in how it judges what a safe change even looks like. Turns out the way it measures risk is surprisingly easy to fool. And this is where it gets kind of bonkers. Let's say the AI wants to use a rare word just a tiny bit more often. PPO sees that, calculates this huge ratio, and totally panics, slamming the brakes on learning. But then, the AI could make a massive, potentially dangerous change to a super common word, and PPO barely even notices. It's like having a security guard who completely freaks out over a fly buzzing in the room, but totally ignores an elephant crashing through the wall. And the researchers themselves, they just hit the nail on the head here. PPO's logic is completely backward, it's way too cautious when it should be flexible, and it's dangerously permissive when it should be careful. This isn't just inefficient, it's a recipe for things to go very, very wrong. This slide just shows you the problem in black and white. That graph on the left, that's the signal PPO is using to make its decisions. Look at it. It's chaotic, it's noisy, it's all over the place. It's like trying to navigate a ship in a hurricane with a compass that's just spinning wildly. Now look at the graph on the right. See how calm and stable that is? That's like a brand new GPS. And the shocking part is that for years, the entire field has been using the broken compass. Okay, so if the old compass is broken, it's time to build a new one, right? And that's exactly what these researchers did. They didn't just point out the problem, they built a much better navigation system. And that brings us to their brilliant solution. Meet Divergence Proximal Policy Optimization, or DPPO. The genius of DPPO is that it just zooms out. Instead of obsessing over the probability change of one random word, it looks at the change to the AI's entire strategy, the whole big picture. It's just a much smarter, more robust way of doing things. Let me put it another way. Think of PPO as that terrible micromanager, you know the type. They see one tiny, insignificant mistake from one random person and immediately decide the whole project is a failure. DPPO, on the other hand, is like the wise, experienced manager who looks at the overall team performance and workflow to figure out the real risk. It's just a way more intelligent way to lead. Okay, I know. This slide looks a little intimidating with the formulas, but trust me, the key difference is incredibly simple. That top formula for PPO, that's the one that gets fooled by this single noisy data point, our buzzing fly. But the bottom formula for DPPO has this little sanity check built right in, that little triangle symbol that looks at the big picture. It's just a smarter, safer way to stay on track. So the theory sounds great, for sure, but does it actually work in the real world? Well, the researchers put DPPO to the ultimate test, a head-to-head battle against the reigning champion and all the other standard methods. And the results are in, and honestly, it's a knockout. Those green and red lines, that's our new DPPO method. They are consistently dominating. They learn faster and they reach higher levels of performance. And check out that third graph. A competing method literally suffers a complete meltdown. Its performance just collapses to zero, while DPPO just keeps on cruising rock solid. And it's not like this was a one-off thing. It doesn't matter if it's a massive 30 billion parameter model on the left or a smaller, more nimble one on the right. In every case, DPPO just comes out on top. It's a clear demonstration of its raw power and its versatility. You don't have to take my word for it. The researchers' own conclusion leaves zero room for doubt. They said that across all their huge experiments, DPPO proved itself to be fundamentally superior in both stability and efficiency. It's a total game changer. And get this, the benefits aren't just in performance, they're also in money, big money. DPPO is so much more efficient that it lets developers completely skip a major, really expensive step in the training process. That saves a staggering 25% on compute costs. In a field where training a single model can cost millions of dollars, that is a massive, massive win. Okay, so we've seen the science, we've seen the results, but what does this all actually mean for the future of AI? Let's zoom out and look at the big picture here and why this one little change could have huge ripple effects. Well, first off, more stable training means fewer expensive, time-wasting failures. That stability leads directly to more efficiency, which lets us build more powerful and capable AIs for less time and less money. And when the cost of building these things goes down, it opens the door for more researchers, more small companies, more creators to build the next generation of AI. It creates this amazing virtuous cycle of progress. So here's the bottom line. By finding and fixing this one single hidden flaw in the very foundation of how we train AI, this research has basically cleared a new, better, and faster path for an entire era of innovation. It's an awesome testament to the importance of questioning our assumptions and a really thrilling glimpse into what's next for AI. It's a really humbling thought, though, isn't it? For years, PPO was considered the gold standard. It was just the way things were done. It really makes you wonder, what other best practices that we all take for granted today are just waiting for a rethink? What other incredible breakthroughs are just sitting there, hiding in plain sight? So today, let's talk about Reddit's massive bet on AI. They're trying to transform their platform from, a bunch of communities into a really powerful answer engine. They're basically banking on artificial intelligence to totally change how all of us find information online. Let's dive in. Okay, let me ask you something. Have you ever been searching for a product review or maybe a fix for some super specific problem, and you type your question into Google, and then you add that one magic word at the end? Reddit? Yeah, if you've done that, you already get the core problem and the huge opportunity that Reddit is going after. I mean, think about it. For almost 20 years now, Reddit has been building one of the biggest archives of human conversation on the entire planet. It's this huge, chaotic, but incredibly valuable vault of real experiences, opinions, and advice. But, finding the good stuff in all that noise, that's always been the big challenge. And this is where you see the fundamental mismatch. See, traditional search, it's all about navigation. It's designed to find you the link, the one correct answer. But Reddit, it's all about the conversation. It's where you go when you have questions that don't have a single right answer, where the real value is hearing a bunch of different perspectives from real people. So what's Reddit's solution to this problem? Well, it's an AI-powered feature they're calling Reddit Answers. And this is their big strategic play to build a search experience that's made specifically for the conversational, human-first content that makes the site so special in the first place. And, CEO Steve Huffman just hits the nail on the head with this quote. What he's basically saying is that Reddit is already the best place for these kinds of complicated questions. So the AI isn't there to replace people. It's there to finally unlock all those valuable perspectives and make them way easier to find. And the end game here isn't to have, two different search bars on the site. Nope. The company is working to combine its classic search with the new AI answers. The idea is that by mashing them together, they'll create a search experience that's just better for pretty much anything you'd want to ask. Okay, so that's the plan. But is it actually working? Well, the early data seems to be screaming yes. This isn't just some plan for the future, it's a strategy that's already got some incredible momentum. I mean, just look at these numbers. The weekly active users for this AI-powered Reddit Answers feature just exploded. It went from 1 million to 15 million in just 3 quarters. That's a 15x jump. It's pretty clear people are hungry for this new way of searching. And it's not just that one feature either. A rising tide lifts all boats. During that same time, Reddit's overall weekly search users, they also grew by a really solid 30%, jumping from 60 million up to 80 million. The focus on search is definitely paying off. So all this success is now fueling something even bigger. This whole AI thing, it's not just about a better search bar. It's a complete rethink of the entire Reddit experience. The new game is personalization for every single person who visits the site, not just the people who are logged in. And it basically boils down to this 4-step plan. Step 1, unify the search. Step 2, make the answers richer with stuff like videos and images. Step 3, and listen, this one is huge. Get rid of the difference between logged in and logged out users, which of course leads right into step 4, use AI to personalize the whole thing for everybody. And this timeline kind of lays it all out. So after that crazy growth in 2025, they're aiming for the 3rd quarter of 2026 to start making this big shift happen, moving towards one single, personalized experience for everyone. It's a pretty ambitious plan to make the site feel more relevant from the very first click. Right, but a huge change like this has to make money, right? And for Reddit, this whole AI strategy is actually opening up some really big new ways to make money, ways that go way beyond their usual ad business. I mean, the numbers really tell the story here. Reddit's other revenue, so that's basically everything that's not ads, is showing some seriously strong growth. It hit $36 million in the 4th quarter of 2025, and for the whole year, it grew 22% to hit $140 million. So what exactly is this other revenue? Okay, so this is where it gets really interesting. That other revenue, it's coming from licensing. Reddit is actually letting other companies pay them to use that giant archive of human chatter, that goldmine we were talking about, to train their own AI models. And this points to a huge trend, right? As the internet gets flooded with AI-generated stuff, real, messy human conversation becomes this incredibly valuable, almost premium resource. So Reddit is cashing in on the very thing that makes it Reddit. And that brings us to the big final question here. Reddit is going all in on becoming the best place to get answers. But in this quest to build the perfect answer machine, is there a risk they could lose that chaotic, lively, superhuman community feel that made it such a goldmine to begin with? That's the billion-dollar question they'll have to answer next. All right, let's talk about something really weird that just happened with Amazon. It's a bit of a paradox, really. Their cloud division, AWS, just had this incredible, record-smashing quarter. But then the company's stock, it tanked. How does that even happen? Well, that's what we're going to break down. Okay, so let's just start with this one number, $35.6 billion. Just let that sink in for a second. That is a huge number, and it's pretty much the core of this whole story. Because that right there is how much money AWS, that's Amazon's cloud division, pulled in during the fourth quarter of 2025. And look, this wasn't just a good quarter. We are talking about their strongest performance in over 3 years. A truly historic moment for them.
So let's really dig into just how massive this success story is. You're looking at a true juggernaut, just operating at its absolute peak.
Here's a key figure for you, 24%. That's the year-over-year revenue growth. It's the biggest jump AWS has seen in 13 quarters. So after things were kind of slowing down for a bit, it looks like they've slammed their foot back on the accelerator. And to put the sheer scale of this into perspective, think about this. Based on this one quarter's performance, AWS is running at a pace to make $142 billion a year. Let me say that again, $142 billion. I mean, this single division of Amazon is big enough to be one of the largest tech companies in the world, all by itself. And hey, it's not just about bringing in a ton of cash. It's about pure profit. The division's operating income saw a huge jump, climbing from $10.6 billion all the way to $12.5 billion in just 1 year. That is just incredible. So the big question is, what's actually driving all this? What's the fuel in the engine for this unbelievable growth? You know, Amazon CEO Andy Jassy, he really said it best. What he's saying here is, yeah, sure, some competitor might post a bigger percentage growth number, but they're starting from a much, much smaller base. Growing by 24% when you're already this gigantic, that's a whole different ballgame. It's an amazing feat. So what's behind it all? Well, it's not any single thing. It's this powerful mix of factors all hitting at once. You've got the AI boom, which is obviously a massive tailwind. You still have big companies finally moving off their own servers and into the cloud. And of course, AWS just keeps landing huge new customers while building out more and more data centers. And just take a look at some of these new clients. We're talking massive deals with industry giants like Salesforce and BlackRock, super innovative AI startups like Perplexity, and even enormous government contracts like with the US Air Force. It just goes to show you they are dominating across pretty much every single sector. Okay, so with a report card this perfect, with numbers this strong, you'd think Wall Street would be popping the champagne, right? But this is where the story takes a really sharp, really unexpected turn. I mean, it seems like a no-brainer, doesn't it? A super important part of your company has its best quarter in years. The stock price has to go up, right? Yeah, not even close. The complete opposite happened. In after-hours trading, right after this amazing news dropped, Amazon stock actually fell by 10%. I mean, what? It was the stunning reversal that had a lot of people, just scratching their heads. So what gives? Why the huge disconnect? To figure this puzzle out, we have to kind of zoom out from AWS for a second and look at the entire Amazon empire. And here is the all-important context. As much of a profit machine as AWS is, it still only made up about 16.6% of Amazon's total money for the quarter. That leaves this other enormous chunk, more than 83% of the company, that investors were also paying very close attention to. And that, right there, is the key to the whole thing. The stock didn't drop because of AWS's amazing performance. Nope, it was a reaction to news about the whole entire Amazon parent company. So 2 things basically spooked the market. First, Amazon said it was going to start spending a lot more money on big ticket items, things like warehouses and data centers. That can hurt short-term profits. And second, the company's overall earnings per share didn't meet Wall Street's predictions. And for investors, that 1-2 punch was more than enough to overshadow all the fantastic news coming out of AWS. So this whole thing leaves us with this really fascinating question for the future, right? As this AI revolution just keeps picking up steam, the demand for what AWS does, that raw cloud power, it's just going to go through the roof. So you have to wonder, are we getting to a point where AWS just becomes so big, so profitable, that the rest of Amazon can't overshadow its success anymore? I mean, you can imagine investors starting to ask for more focus on AWS, maybe even whispers of spinning it off someday. Now that is the paradox to keep an eye on.